Hello viewers, Moments question 2. So we have two rectangular blocks, each of which have a screw in the bottom left corner, which is going to make that the pivot of any rotation that occurs here. So in both cases, we have a 9 Newton force acting at the upper left corner and an unknown force in the lower right corner, and we need to find that force that puts the situation in equilibrium, at least as far as rotation goes. So that means we need the sum of the moments to be 0. Okay, so like we did with question 1, let's take the clockwise direction to be positive for the purposes of this question. And we need to look at which direction each of these forces is going to make the object rotate. So let's look at this 9 Newton force. Okay, so that 9 Newton force is going to make it rotate in the clockwise direction, whereas F here is going to make it rotate anti-clockwise. So our clockwise moment is going to be, for question A, 9 times 3, and our anti-clockwise, which is going to be negative, is 5 times F. And if it's not going to rotate in either direction, we need that to be 0. So therefore 5F equals 9 times 3 is 27, and therefore that unknown force must be 27 divided by 5, which is 5.4 newtons. So that's the force that's required to be pushing up here in order to cancel out the rotation clockwise from the 9 Newton force. We need this force to be 5.4 newtons for the sum of the moments to be 0, so that there is no rotation. Question B here, at first glance it looks to be the same, but if we look at this 9 Newton force, what's its line of action? It's going straight through the pivot, and that means that the perpendicular distance of the force is going to be 0, not 3 metres, but 0 here. So we've got, for question B, the force is 9, multiplied by perpendicular distance is actually 0, minus the force, so nothing has been changed in this lower right corner here. So that's still going to be F times 5 equals 0. So therefore 9 times 0 is 0. So we've got 0 minus F times 5 equals 0. So therefore 5F equals 0, which means that the force must be 0. So there's only going to be no rotation if there is 0 force down here, which makes sense because this is not actually providing a clockwise or an anti-clockwise moment, so there is no clockwise moment due to this 9 Newton force, and therefore the other force here also cannot be providing a moment, and therefore, since its perpendicular distance is still 5, that force needs to be 0. Okay, thanks for watching. Over and out.